Good day, everyone. It's me again, Ma'am Yumi, and I'm here to discuss probability. Okay, so what is probability? So probability of an event. If S is the sample space of an experiment and E is an event associated with the experiment, the probability of E denoted by P of E is defined by this formula. Okay, so the number of outcomes in your event over the number of outcomes in your sample space. So how do we define event and sample space? Pag sinabi po natin sample space, this is the list of all possible outcomes, while an event is just an outcome of your sample space. Okay? Probability value ranges from 0 to 1. So hindi pwedeng maging negative ang probability, hindi din siya pwedeng sumobra sa 1. Okay, so to further understand the concept, let's have this example. So in first example natin, determine the probability of each of the following events. Letter A, obtaining a 5 on a throw of a single die. Okay, so we all know na a die has 6 possible outcomes. Okay, so we're looking for the probability of obtaining a 5. Okay, so that's gonna be your event. Okay, and counting this outcome in your event, you only have 1. That is obtaining an outcome of 5. Going to sample space, you have 6 possible outcomes in throwing a single die. So counting these outcomes, you have 6 as the number of possible outcomes. Solving for your probability, number of event over the number of outcome, or number of sample space, you have now 1 over 6. Okay, so that's the probability of obtaining a 5 on a throw of a single die. What about this one? What's the probability of obtaining a head on a toss of a coin? Okay, so the event defined here is obtaining a head. And this has only 1 outcome in your event. So the number of outcome in your event is 1. Your sample space is defined as head and tail. So that's possible outcomes in your sample space. Okay, so counting this outcome, you have 2. Therefore, the probability of obtaining a head is 1 over 2 or 1/2. Okay, what about this one? Outcome of 2 dice being thrown. Okay, so you have here the outcomes of 2 dice being thrown. Okay, so yung first value natin dito sa loob ng parenthesis will represent the outcome of your die 1, and then the second value here will represent the outcome of your die 2. Okay? Ayan, your sample space is 36. Bakit po 36? Kasi mathematically, the outcome in your first die is 6. The outcome in your second die is 6. 6 possible outcomes. So by FPC, we multiply. Therefore, we have 36 possible outcomes. So these are the 36 outcomes of throwing 2 dice. Okay, so the first probability asked is obtaining a sum of 7. So how do we get that? And the next problem is the probability of obtaining a sum of 5. Okay, so let's solve first the first problem. So given the sample space 36, the probability of obtaining a sum of 7 would be, okay, so ito yung mga event natin. These are the outcomes na pag inad natin yung outcome niya, ang sum niya is 7. So 6 plus 1 is 7, 5 plus 2, 4 plus 3, 3 plus 4, 2 plus 5, 1 plus 6. Okay, so counting these outcomes in your event, you have 6 possible outcomes. Okay, over the total number of outcomes in your sample space is 36. Therefore, the probability of obtaining a sum of 7, this would be 7, is 6 over 36 or 1 over 6. Okay, so palitan na natin dito. Ayan, para hindi tayo malito. Ayan. So the sum of 7 is 6 over 36 or 1 over 6. So let's continue. Okay, for letter D, what is the probability of obtaining a sum of 5? Again, let's look at those outcomes. So you have 4 plus 1, 3 plus 3 and 2, 2 and 3, 1 and 4. So take note, when you add these outcomes, it will give us a sum of 5. Obviously, we have 4 outcomes in your event. Okay, so solving for the probability, okay, the probability of obtaining a sum of 5 is 4 over 36 or 1 over 9. You can also present your probability in terms of percent. Okay, so dito sa illustration natin, in fractional form siya. Okay, let's continue. Okay, one of the theorems in probability is the conjunction probability. So this type of probability is associated with events happening together, one event and another event occurring at the same time. Events, however, may be independent or dependent. So how are we going to know that the probability is under this particular theorem, under conjunction? So usually, may encounter natin yung conjunction na end. And this end corresponds to the operation of multiplication. Okay. So how do we solve problems under conjunction probability? Okay, let's have the first case. Okay, when the occurrence of one event does not influence the probability of the occurrence of the other event, these events are said to be independent. So usually, ang makikita natin sa mga statement, sa mga problems, Jan, would be looking for the probability that A and B will happen. Okay, you have the conjunction and. So whenever you're given this one, all you have to do is multiply the probability of A and probability of B. So let's have this example. At birth, the probability that US female will survive to age 65 is approximately 8 over 10. Okay, so the probability of surviving for female is 8 over 10 as denoted by this one. The probability that a male will survive to age 65 is approximately 2 over 3, denoted by this probability M over S. Ayan. Okay, so indicate lang natin yung given na probabilities. This is the probability that female will survive, and this is the probability that male will survive. Okay, given this class, we can actually determine kung ano yung probability that female will not survive and male will not survive. So how do we do that? Okay, so balikan natin yung mga theorem sa sets. Okay, so this is the complementary, di ba? So for us to be able to get the probability that female will not survive, all you have to do is subtract this 8 over 10 from 1. So the probability that female will not survive is 2 over 10. Okay, similarly, the probability that male will not survive is 1 over 3, or the formula of that is 1 minus 2/3. Okay, so let's have the first problem. So ang problem natin would be, what is the probability that both male and female will be alive at age 65? Okay? So this is the same as getting the probability that both female and male will survive. Take note of the conjunction na end. Okay, so given this, all you have to do is multiply the probability that female will survive and male will survive. So that's gonna be, okay, 8 over 10 times 2/3. So we have this as our final answer. 16 over 30 or 8 over 15 or 0.53. Next. So what is the probability that only the male will be alive at age 65? Take note, the question here is only the male. Okay, so iba naman pag ang hinihingi is probability that male will survive lang. Pag tinanong tayo, what's the probability that male will survive? Of course, the answer will be 2/3. Pero pag ang tanong would be, what is the probability that only the male will be alive or will survive? The answer would be, or the solution would be this one. So we get the probability that male will survive and female will not survive. Again, by the formula, okay, we multiply the probability that male will survive times the probability that female will not, okay, will not survive. So that's gonna be 2 over 3 times 2 over 10. So that gives us 4 over 30 or 2 over 15 or 0.13. Okay, let's go to the next case. Next case would be, under pa rin siya sa conjunction probability, but this is on conditional events. So when the occurrence of one event is conditioned by the other event, these events are said to be conditional. So the example is, let us take a box containing 5 coins, 3 of which are 50 cents and 2 of which are 1 peso coins. If we draw 2 coins from the box without replacement, what is the probability that the first coin drawn is 50 centavos and the second is 1 peso? Okay, so let's have the first coin muna. Okay, so yung first coin natin would be 3 over 5 kasi you have 350 cents over 5 kasi you have 5 coins. Considering that the first event would be getting a coin of 50 cents. Okay, so the next one is getting 1 peso. So sabi kasi dito without replacement. So yung sample space natin, mababawasan na ng isa. So you have 2 1 peso coins, so that's going to be over 4 na lang. Okay, so ito, kaya siya tinawag na conditional kasi this event depends on the first event. Okay, so multiplying, you have 6/20 or 3/10. Okay, let's go to disjunction probability naman. So this type of probability is associated with several events that happen either separately or simultaneously. Disjunction probability is concerned with either or relationship. So take note of this conjunction na or. So this time, ang may encounter, ang keyword naman natin is this conjunction. So ito yung makikita natin sa statement. Usually, whenever we encounter this is associated with the operation of addition. So kung dun sa conjunction, minultiply natin yung probability, dito sa disjunction probability, we're going to add them. Okay, let's have the first example. Okay, sabi dito, what is the probability that in a single toss of a 2 dice, the sum will be 8 or 10? Okay? Ayan. So take note, yung sum of 8, okay, ito yon. So just count the number of outcomes. Diba, you have 5/36 plus sum of 10. So you add these outcomes na ang sum niya is 10. So adding that, kasi nga diba, or is associated with addition. So you have 8/36 or 2/9. Okay, next example. Okay, so another case would be, there are also cases of joint events which are not mutually exclusive because there are some elements common to both events. Okay, example. Take a math class with 52 students, 32 of whom are male and the rest are females. A total of 21 of the females and 15 of the females get a grade above 90. So what is the probability that if a student is chosen at random, this student has either grade of above 90 or is a male? Okay, take note. We're getting the probability that the event is above 90, or the student that we're going to choose is above 90, has a grade of above 90 or male. Okay, so how do we do this? Take note, meron tayong probability or event na which belongs to both. Okay, pwedeng maging A or B. In this case, yung student natin or respondent natin, pwedeng magkaroon ng grade above 90 and at the same time, male siya. Okay, so how do we get the probability? You get the probability na above 90 plus probability na male minus tanggalin natin yung probability na above 90 siya at the same time male. Okay, so yung above 90, all you have to do is just add this one, 21 and 15, kasi regardless of the gender, kung lalaki or babae. So 21 plus 15 is 36. Probability na male is 32 with this data. And then we subtract. Ilan yung students na nakakuha ng above 90 at the same time male? Okay, so that's going to be 21 from this data. Okay, so during the operation, we'll have 47/52. Okay, so next would be probabilities involving qualitative data in contingency table. Usually, yung mga data natin is arranged in a table, specifically a contingency table. Pag sinabi natin contingency table, naka-cross-tabulate yung table natin, yung variables natin. For example, this one, cross-tabulated yung gender and then yung status ng if it's vegetarian or non-vegetarian. Okay, let's have the first case. Ang first case natin is finding the probability of a single event from qualitative data. Okay, single event lang. Pag sinabi natin single event, we're finding the probability na vegetarian lang siya or non-vegetarian, male or female lang. Okay? So how do we get the probability? Simply divide the subtotal of the desired event by the grand total. Example, the probability that a person is vegetarian. Okay, so sabi dito, kunin lang natin yung subtotal na vegetarian, okay, over the grand total. So as simple as that. So our answer will be 40/80. Okay? Again, we get the probability or subtotal na vegetarian over the grand total. Okay, next case. This is to find the conjunction probabilities of two independent events from qualitative data. Divide the observed frequency where the two events intersect by the grand total. Okay, this time we're looking for the probability that A and B occur. Okay? So how do we do that? Let's have this example. So we're asked to get the probability that a person is female and a vegetarian. Okay. So dito, female and vegetarian, kukunin lang natin dito ang intersection na female at the same time vegetarian siya. Okay, that's 22 over the grand total. Ganun lang kadali. You get the intersection again over the grand total. Okay, so that's the second case. Ito, pag pinagpalit naman natin, kunwari instead na female and vegetarian, ginawa nating vegetarian and female, pareho pa rin yung magiging sagot niya. Okay, let's have the third case. The third case is to find the probabilities of two dependent events from qualitative data, divide the observed frequency where the two events intersect by the subtotal of the event which is used as a condition. This time, conditional probability. Okay? Paano natin malalaman na nagpo-fall siya dito sa conditional probability? Okay, let's have this example. The probability of getting a male at random provided that he is non-vegetarian. So ang conditional word dito will be this provided. Okay, may mga iba naman na problem na imbis na gumagamit ng provided, ang ini-indicate nila will be given that o kaya with the condition. Okay, so statements like that would fall under conditional probability or under this case. Okay, let's go back to the problem. So this is getting the probability of getting a male at random provided that he is a non-vegetarian. So what do? Kunin muna natin intersection na male siya at the same time non-vegetarian. So that would be 20. Pero this time, your denominator will not be the grand total, but instead, your denominator will be ito, yung conditional event, which is non-vegetarian. So that's gonna be over 43. Okay? So male provided non-vegetarian, 20 over 43. Okay, what about kung ang problem natin is baliktad? Ang kinuha natin is non-vegetarian provided he is a male. Okay, pareho pa rin klase yung numerator pero take note of the difference. Ang denominator niya would be the subtotal na male. Okay? Kasi ang conditional event natin is male. Okay, so ito yung naging denominator niya. Okay, let's go to the last case, which is finding the disjunction probabilities of the two events. Okay, this time we encounter the conjunction ng or. So medyo mahaba lang yung solution niya, ano? Okay? So let's have this example. So the probability of getting a female or a person who is a non-vegetarian. Okay, so the solution would be, ayan, you get the probability na female, you get the probability na non-vegetarian, minus the probability na female and at the same time non-vegetarian siya. So una, you get the probability na female. So ito yon, female 45 over 83 plus you get the probability na non-vegetarian. So ito yon, total ng non-vegetarian over the grand total minus you get the intersection na female at the same time non-vegetarian. So that's 23 over 83. And then we perform the operation that will give us 65 over 83. Okay, so I hope you understand the concept on probability and then in applications ng theorems on conjunction, disjunction, and then probabilities of data in contingency table. So thank you very much for listening.